Now the next question says a point charge. So let's state out our parameters. Q1, the point charge, is positive 3.0 times 10 raised to the power of minus 6 coulomb. Is 120 centimeter distance, means our arrow 120 centimeter, which we can convert to meter by dividing by 100, and this gives us 1.2 meter. From a second charge, Q2 is equal to 1.5 times 10 raised to the power of minus 6 coulomb. Calculate the magnitude of the force on each charge. Now the magnitude of the force can be calculated using the Coulomb's law, which states that F is equal to K Q1 Q2 all over R square. So our F will be equal to K is a constant, 9.0 times 10 raised to the power of 9. Q1 is 3.0 times 10 raised to the power of minus 6. Then Q2 is 1.5 times 10 raised to the power of minus 6 divided by R square, which is 1.2 square. Now when we calculate this, if you multiply this and then divide, that is to say simplify what is here, our final answer for F will be equal to 0.0281 Newton, which we can then count backward. How many times? 2 times to give us 2.81 times 10 raised to the power. How many times do we count backward? 2 times. So times 10 raised to the power of minus 2 Newton. So this is the correct answer to that question. 2.81 times 10 raised to the power of minus 2 Newton. And that is option C. That is option C. Now let's proceed with the next question. The next question says that a uniform electric field. The electric field is given as 6I plus 3J Newton per coulomb intersects a surface of area A. The area is given as what? A. It was given as A. The value was not given. Determine the flux through the area if the surface lies on the SY plane. Now the flux, the electric flux is given by E times A. The electric flux is given by the electric field times the area, that is what? Perpendicular. Now the area was given as A. So we must find the electric field intensity. But the electric field intensity was given in unit vector formation. So we must be able to calculate the magnitude of the electric field intensity. Now to calculate the magnitude of unit vectors, what we usually do, we can say the magnitude of E will be the square roots of what? 6 square plus 3 square, from our understanding of vectors in our first semester. To calculate the magnitude of any stated vector, what you do is to find the resultant, which is what? The square root of the first one, which is 6, plus that of the second one, which is 3. And this will give us the root of 6 square is 36 plus 3 square is 9. And that will give us the root of 36 plus 9 is 45. Okay, so our E is root of 45. So substituting in here, we can say this is root. Our electric field intensity is 45, root 45 times. Then the area perpendicular was given as what? A. It was given as a. No numerical value was given for that. So our electric field intensity, or the electric flux, is root of 45A. And that is option C, the correct answer. Let's go to the next question. If the size of the charge are tripled for both point charges maintained at constant separation, the mutual force between them will be changed by what factor? Now from the Coulomb's law, we say that our F is K Q1 Q2 all over R square. Now if Q1 is tripled, it means that the other force will be what? K. The Q1 is tripled, so we have 3Q then times Now the two charges are tripled. It means Q1 is tripled and Q2 is also tripled. So this will be 3Q2 all over. The distance of separation still remains the same, so we have R square. Now what will be the magnitude of the force for the tripled one? Let's use F3. F3 now will be equals to K times 3Q1 times 3Q2. 3 times 3 will give us what? 9Q1 Q2 all over R square. Now F3 will be equals to, if we take this 9 out, use this 9 to multiply 3, gives us 9K Q1 Q2 all over R square. So our F3, which is the force for the tripled one, will be 9K Q1 Q2 all over R square. But we know that our K Q1 Q2 all over R square is equal to F. K Q1 Q2 all over R square is equals to what? F. So our F3 is 9. In place of K Q1 Q2 all over R square, we can put what? F, and that is 9F. So the force between them will be increased or will be changed by a factor of 9. To change by a factor of 9, and that is the answer to that question. Let's take the next question. Now the next question says 2-point charges. The charges Q1 is equals to 15 microcoulomb and Q2 is equals to 10 microcoulomb. Then the distance of separation is 12 centimeter, which of course we can convert to meter by dividing by 100, and this gives us 0.12 meter. Estimate the work done in bringing them 7 centimeter closer, given that the 15 microcoulomb charge is at fixed position. Now for us to calculate the work done in bringing them together, first of all, we need to calculate the potentials at each of the distances and then find the potential difference. The potential difference will give us the work done in bringing them together. So first of all, let's calculate the potentials in bringing them together. Now that will give us V is equals to K Q1 Q2 all over R. That is the formula for two charges. The potentials of two charges at a distance of separation is given by K Q1 Q2 all over R square. So for the 12 centimeter apart, it will be equal to 9.0 times 10 raised to the power of 9 times what is Q1? 15 microcoulomb, which is 15 times 10 raised to the power of that is 15 times 10 raised to the power of minus 6 times the next one is 10 microcoulomb, 10 times 10 raised to the power of minus 6 all over our arrow. Distance of separation is 0.12 meter. So the potential at 12 is equal to now everything on top here will give us everything on top. When you simplify everything on top here, that will give us to give us 1.35. Then everything under, of course we know under is just 0.12 meter, and that will give us everything together here 11.25. okay, now the next one is they told you that it was brought 7 centimeter closer. So if initially, let's say this is Q1 and this is Q2, now they told you that the 15 microcoulomb was constant, so it means 15 was constant and then Q2 was moved. Now if the distance of separation was initially 12 centimeter and then you brought 7 centimeter closer, that is to say the distance from where you carried it to where you are now is, let's say, about 7 centimeter. This is now our present Q2, the distance it is, and this is your Q1. So what is the distance of separation between Q2 and Q1? It will be the 12 minus what? 7. You must take cognizance of this. if initially it was 12 centimeter apart, then you brought it 7 centimeter closer, I used to say that it is now what 5 centimeter what apart, because you brought it what 7 centimeter closer. The initial distance was 12, then you brought it 7 centimeter closer. The present distance between them now will now be what 5 centimeter. Okay, so the present distance between Q2 and Q1 is 5 centimeter, and that is what you are going to work with, not the 7 centimeter. So we can say V of 5 centimeter will be equal to, now 5 centimeter to meter, distance will be what 0.05 meter, and this will be 9.0 times 10 raised to the power of 9 times 15 times 10 raised to the power of minus 6 times 10 times 10 raised to the power of minus 6 divided by, then we'll have 0.05 square. Now when you simplify this, our V at 5, the potential at 5, is equal to, simplify what is on top, automatically you know this will give us 1.35. Then what is under will give us, I believe, 0. Okay, this is not squared, so let's remove this square from here. This will give us 0.05, and then when you simplify this, it's going to give us 27 volts. So this is 27 volts. Okay, this is the 27 volts, or sorry, 27 the work done, 27 joules. The work done, what we'll be working with since is the work done. Okay, the work done. Now I'm going to prove this formula when we are done with everything. I'm going to prove how we got this formula. Everything we'll be working with is the what, the work done. Work done. Now this is 27 joules, this is 11.25 joules. Now to calculate the work done in bringing them together, it will be the difference between this and this. Now the difference between those two will be what? Let's do that quickly. The difference, the work done, will be equals to the difference between 27 joules and 11.25 joules. Now W will be equals to 27 joules minus 11.25 joules is what? 15.75 joules. So our correct answer is 15.75 joules. So the first thing we need to do is to calculate the work done at each point, and then from there we can now subtract the work done between the 2 points, and then it will give us the final work done. Now how did we actually arrive at this formula? Can we do that together? How did we arrive at that formula, which is V is equals to K Q1 Q2 all over R? Now recall that work done is force times distance, and then our force is what? K Q1 Q2 all over R square. Now the distance is usually represented with R. Are we getting down? So R cancel one of the R here. Your work done will be what? K. Work done will be K Q1 Q2 all over what? R. So if you are asking how did we arrive at this formula of K Q1 Q2 all over R, is from what? The formula for work done, force times distance. Our force is K Q1 Q2 all over R squared times what? R. So that is the answer to that question. It's pretty easy. First of all, calculate the work done at the distances apart, then calculate the work done when they are brought when they bring them closer. Then at the end of the day, separate the differences in their work done to get the total work done. Okay, that would be that. Now the electric potential difference between 2 points in an electric field is defined as the electric potential difference V is the work done in bringing a unit positive charge from infinity to that point, or from one point to another. So the work done in carrying a test charge from one point to another is called the electric potential, and that makes option D the correct answer. The work done in carrying a test charge from one point to another. Now the next question: what is the magnitude of the electric field intensity of a point 10 centimeter from a charge of 10 microcoulomb. First of all, let's take our parameters. We have 10 centimeter or centimeter rather. Now divide both sides by 100. This gives us 0.1 meter. Now the next thing we need to do is the charge. The charge Q is what? 10 microcoulomb. 10 microcoulomb is how many coulomb? 10 raised to the power of minus 10 coulomb. Okay. Now what is the formula for the electric field intensity? The formula is K Q1 or KQ all over R square. Where our Q is the point charge, K is a constant, and then your E will be K constant is 9.0 times 10 raised to the power of 9. Q is 10 times 10 raised to the power of minus 6, and then your R is 0.1 square. Now when you simplify this, you're going to get the answer to this question. That will give us 9 times 10 raised to the power of 6 Newton per coulomb. And that is the answer to that question. 9 times 10 raised to the power of 6 Newton per coulomb. A Newton per coulomb. Yeah, that is the correct answer to that question. Option A is the correct answer. Now, sometimes you may be given questions like this. There are cases when you need to use the formula E is equals to F over Q. This is also a formula for the electric field intensity. Now that is when you are given the force and the charge. But in a situation where you are given the charge alone, and then they say they gave you the distance of separation R, it means you have no option than to use what? KQ all over R square. And that is the one that we actually used for this question. So that is the correct answer to that question. Now let's look at the next question. The electric potential difference between 2 points. Okay, we've answered this question before. The correct answer is D. Now, you are given these questions. 2-point charges Q1 is equals to that, and Q2 are arranged along the S axis. Along the axis at S is equals to 0. So one of the S is what? 0. And the other, let's say S1, and the other is 4.0 centimeter. So let's say you have the charges like this. One is minus 10 microcoulomb. Okay, let me put that one up. The charge is up, minus 10 microcoulomb, and the other is minus 2 microcoulomb. The distance of separation is what? 0 and 4 centimeter respectively. Find the position along the x-axis when the potential will be what? 0. Let's say that position here is what? Is x. The position there is x. At this position, the potential V will be equals to 0. Now, how do we calculate the distances from these charges to that position? Now, you agree with me that from 0 to x is what? Is x. Because x minus 0 is what? X. So for the 10 microcoulomb charge, the distance from their place to the point where the potential will be 0 will be what? X. So that will be x. Now how about this one? What will be the distance from this point to the point where the potential will be 0? It will be what? 4 minus what? S. That is the distance between here and here. Okay, the differences between the distance, and 4 minus s is what? 4 minus s. So this is s because 0 minus s will give us s, and this is 4 minus s because 4 minus s will give us 4 minus x here. Now at this point, what do you think we can actually do? We can use our formula for the potential difference to calculate. Now we said that the potential difference V, we can calculate it using the formula of K Q1 Q2 then all over R. K Q1 Q2 all over R. Now, but because we are talking about two charges, we can decide to take it as V is K Q1 Q2 then bracket 1 over R1 minus 1 over R2. This is the formula we are going to use to solve this problem. 1 over R1 minus 1 over R2. Now, how do we go about with this question? Now, let's substitute in our R1 and R2. Of course, we said our R1 is the first distance, okay? Which is for the first charge, which is x. and then your R2 is what? 4 minus x. We've shown you how we got that. So our V will be equal to K is 9.0 times 10 raised to the power of 9 times R1 is what? Minus 10 times 10 raised to the power of 6. The other one is minus 2 times 10 raised to the power of minus 6. Then bracket 1 over x minus 1 over 4 minus x. 4 minus x. This is minus x here. Now, they told you that at what point will the potential be 0? So it means that V is supposed to be 0 is equal to. Now, when you simplify everything you have here, so that we have enough space to write out the other parameters, everything you have here will give us 0.18. That is 9.0 times 10 raised to the power of 9 times minus 10 times 10 raised to the power of minus 6 times minus 2 times 10 raised to the power of minus 6. Then times, you are going to have 1 over x minus 1 over 4 minus x. Now I can easily erase this. So that we have enough space to solve. This will be 0 is equals to 0.18 times. What is the LCM of x and 4 minus x? Of course, it's s bracket 4 minus x. Okay? Now, this is divided by. When this divide this, what are we left with? 4 minus s, because s will cancel s. So 4 minus s times 1 will give us what? 4 minus x. When this divide this, what is it going to give to us? It's going to give us what? X. Because 4 minus s cancel 4 minus s. So this will be what? Minus x. And then your 0 equals to 0.18 times 4 minus s minus s is what? Minus 2x. Then everything under here will give us s bracket 4 minus what? X. This is over 1. We can cross multiply. Anything multiplied by 0 will give us what? 0. Okay? So if it gives us 0, if that gives us 0, it means that when this multiplied by this, let me show you the point. When this multiply by this, it will give us 0. So this will be 0 is equals to 1 times everything here will give us, this will be 0. Okay, this is in brackets. Please take note. 0.18 bracket 4 minus 2x. This will be 0. 0.18 times 4 will give us 0.72. 0.18 times minus 2s will give us minus what? 3.6 minus 0.36x. So to make s out of the formula, take s to this side, becomes 0.36x, because when this one crosses to this side becomes what? Positive, is equals to 0.72. To get s, divide both sides by 0.36, and your x is equal to 2 centimeters. So the point at which the potential difference or the potential will be 0 is at 2 centimeters, and that is the answer to that question. Use the formula. V is equals to K Q1 Q2, then brackets 1 over R1 minus 1 over R2. At this point, when V, substitute V is equals to 0, substitute in Q1 and Q2, look for R1 and what? R2. You're going to have your answer. So that's the correct answer to that question. Now, you have another question. 2-point charges of plus 2 microcoulomb plus 2.0 times plus 2 microcoulomb are placed 0.3 meter apart. What are the magnitude and direction of the forces each exert on each other? Now, your Q1 is equal to Q2, and that is equal to plus 2.0 times 10 raised to the power of minus 6 coulomb. Your R, the distance of separation, 0.30 meter. Now, when we are talking about the force of attraction, what should come to our mind is the Coulomb force, which is F is K Q1 Q2 all over r square. Your F will be equal to 9.0 times 10 raised to the power of 9 times, now your Q1 is equal to Q2, and that value is what? 2.0 times 10 raised to the power of minus 6 times 2.0 times 10 raised to the power of minus 6. Now everything will be all over r square, which is 0.3 square. Okay, your F will be equals to, when you calculate this with your calculator, when you punch this with your calculator, you're going to have the following answer. You're going to have 0.4 Newton, and then 0.4 Newton, if you count this forward once, F will be what? 4.0 times 10 raised to the power of minus 1, because you counted forward once, Newton. And then the correct answer to that question is option B, 4.0 times 10 raised to the power of minus 1 Newton. Now you have another question. Two charged small spheres are distance arrow apart. Now they gave you the distance, which is arrow apart, and exert an electrostatic force F on each other. It means the force given to you is equal to F if the distance is halved. Now they are telling you that if arrow now is halved, the force exerted on each other will be, what will be the force if arrow is half? Now from the Coulomb's law, F is equals to what? K Q1 Q2 all over r square. Normally, are we getting it now? Your F was given to you, then you have K Q1 Q2. Now your arrow was given as capital letter what? Arrow, then we have what? Square. Now for the second instance, you have K Q1 Q2 all over. This for the first instance. Now for the second instance, now this to say when arrow is halved, it means our arrow here will be what? Arrow over 2. So this becomes arrow over 2 square. That's what we substitute for arrow over 2 square. And this will give us F, then arrow over 2 will be equal to K Q1 Q2 all over r square divided by 4, which we can also write as F r over 2 is equals to K Q1 Q2 divided by r square over 4. Division means 4 will come up. If you change this to multiplication, it means 4 will come up and r square will come down. So F r over 2 will be K Q1 Q2 times 4 all over r square. Okay, now F over r2 will be equal to, what are you now going to have? It's going to give us 4 multiplied by everything here, give us 4K Q1 Q2 all over r square. But we know that our KQ1 Q2 over r square is equals to what? F. Is equals to what? F. So in place of that, we can say that our F, in place of this, we can substitute in F. Okay, in place of this, so our answer will be what? 4F, because we said KQ1 Q2 all over r square is F. So our F arrow over 2, the force will be what? 4 times the initial force, which is 4F, and that is option C, the correct answer. Now as you walk across a synthetic fiber rug on a cold dried winter, you pick up an excess of minus 65 microcoulomb. What is the charge on the rug as a result of your walking across? Now the law of conservation of charge states that whenever a charge is created, an equal amount of that charge but different in sign will be simultaneously created, so that the total charge in the system will be conserved. The total charge in the system will be what? 0. So in a situation where you created, let's say 20 microcoulomb charge, an equal of 20 but an opposite sign will be created, and that is what? Minus 20 microcoulomb. Such a way that when you sum these two together, it will be 20 microcoulomb minus 20 microcoulomb, and this will be what? 0. That is to say that the total charge is conserved. Now same thing is applicable when you have plus 65. Let's say you have minus 65 microcoulomb charge is created. That means to say you picked an excess of minus 65, rather is minus 65. What is the charge on the rug as a result? As you create a minus 65 microcoulomb charge, an equal amount, which is positive what? 65 microcoulomb charge will be simultaneously created. So the correct answer is plus 65 microcoulomb. Now let's assume you created let's say minus 6 or minus 10 microcoulomb. What will be simultaneously created to be what? Can you guess the answer? This will be plus 10 microcoulomb charge, and that is the answer to that question. And I believe that we've come to the end of the calculations in electrostatics. More solvings calculations are coming, but then you make do with this one. Make sure you subscribe to the channel, turn on the notification button, and also share. Comment on the comment section what you think we can improve on. Thank you.